Hi everyone, welcome to another video of Machine Learning from Data. This is lecture 2, and in this lecture we are going to cover a couple of things, and I've tried to summarize them here. The first thing that we're looking at is a simple yet powerful learning model that's known as the Perceptron. So we're going to discuss that, try to understand that. We'll relook at the learning setup and also try to understand how the model that we are going to derive today fits into the larger picture of learning that we looked at in the previous lecture. And then we'll discuss PLA, which is nothing but the perceptron learning algorithm. I'll also summarize some other views of learning, some other ways in which we can learn from a given data, different perspectives of learning, and 3 important paradigms of learning: that's supervised, unsupervised, and reinforcement learning. Okay, so let us begin. Now let's review or recap what we did or what we said in the previous lecture. So in the previous lecture, we formalized the components of learning and we talked about this picture, which is nothing but the learning process. Now in today's lecture, we are going to build on this and see how different components of a model that we derive today fall into place in this particular picture here. Just to review what we already said, right? There is always this underlying target function which we are trying to figure out in some ways, and obviously we cannot figure that out because this is completely unknown. If we think of the credit card problem in specific, there is this ideal formula that exists, right? That kind of links the input vector, like the features of the customers, things about the customer, to the outcome, which is approving or denying a credit card application, right? So there is that ideal formula that somehow exists. We don't know that, right? But we do know, and I would say we do have the data, right? So we have data, we have examples that link this X, which is my input, like the attributes, to an output, which is my Y, right? Whether this application was approved or not, whether this person defaulted or not, and so on, right? So I have the data, which is an outcome of that unknown target function, right? The other thing that we talked about was the hypothesis set. This was nothing but a set of functions, and it could be like an infinite set of functions. That could be the set of candidate formulas that we can use in order to determine my final hypothesis G. But one thing that we said, one thing that connects the training examples and the hypotheses was my learning algorithm A, right? This comes in between, and this eventually leads us to the final hypothesis, that's G, and we try to come up with a G that's as close to F as possible. Okay, so there were a few assumptions that we talked about. The very first assumption was that we need to fix the set of candidate formulas H, which is my hypothesis set, before I see the data. So that's the first thing. And again, before we see the data, so we cannot see the data, that's assumption number 1. That means I cannot see this before I set this up. This was assumption number 1 in this entire learning process. The second thing is that this learning algorithm, it has to pick that one hypothesis based on my input, which is my data here, and come up with G. So how will it do that, right? Because I said that I can have like any number of formulas here that forms my hypothesis set. Well, so that's what we are going to discuss in today's lecture, that this learning algorithm should figure out a criteria to pick one of these H, right? And also implement that criteria. So what the role of the learning algorithm in this entire process is that it should figure out a criteria. That's number 1. Like there has to be some basis based on which my learning algorithm is picking one of these. Like this can have like H1, H2, H3, and so on, right? So let's say I'm picking some Hn, and that becomes my G, right? So this is based off of some criteria, and that we'll see. And also it should be able to implement that criteria, right? It should be able to implement the set of steps that kind of are logical in picking up that eventual H of n, which we will call G, right? And in terms of notation, the learning algorithm and the hypotheses that we have, the set of hypotheses, these together are known as the learning model. Right? So whenever going forward, we are going to talk about a model, a learning model. It's nothing but the learning algorithm and the hypothesis set combined together. Right? So together they form something that's known as a learning model, which we will refer to throughout the course. Okay, so this kind of summarized what we did in the previous lecture, and now in today's lecture, we are going to talk about a simple learning model, and we are going to derive it from whatever information we have of that model. Okay, so let's move forward then. Now again, this was taken from the previous lecture where we formalized some components of learning by looking at this credit card application problem. And let's take this forward. So the credit card application or approval problem was that we have these applicants that come and ask the bank to give them approval for a credit card, right? And the bank's role here is to approve or deny. And the basis for that is essentially their data, right? And the data that we have is their salary, their debt, years in residence, and so on. Like, it could be many factors, I don't know, right? So that's my input, and the way I mathematically represent it is X. My output is whether I'm going to deny or accept the application, and that is my Y, that's my output, and I've encoded it as a +1 or a -1 depending on a yes or no. We know that there is a target function that links or that maps X to Y, and it is unknown, of course, and that's the whole point of using data in order to solve this problem. That's the whole point of having or utilizing data on customers and then formalizing it as a learning problem, right? So the way we are going to derive this learning model as such that we are talking about today, which is the perceptron, is by using this particular problem. Let's assume that we are having this problem, and then using that, I'm trying to find out whether an unknown customer or a new customer, when they come in, whether I should approve or decline their application. Okay, so how should we do that? How should we formalize this credit card approval problem? Okay, so let's begin. So I have this input X that I just talked about, right? So I have my input, and this X actually determines it represents a customer, right? And in the very first lecture, we said that this is nothing but a vector of attributes, right? So basically, as I said in the previous slide, if you remember, this is going to be like, this is my attribute number 1, attribute number 2, attribute number 3, and so on, right? So this is what I have. My input is nothing but a vector of like x1. I'm denoting each of the factors or attributes with x, right? So x2, x3, and so on, right? So I have this like vector of features in d-dimensional space. So I'll have eventually xd, and this is a d-dimensional space, just to make it clear. And yes, yeah. So this is a d-dimensional space, and this is a vector of features that I have, right? Okay. So now I need to come up with some final value based on which I'm going to accept or deny an incoming request, right? So one way of doing it, and there could be multiple ways of doing it, of course, but one way of doing it is to, how about like give some level of importance to each of these features, right? Based on, let's say I have some domain knowledge. So I said maybe this is salary, and this is debt, and maybe this is years, maybe we have age of customer, and so on, right? So based on that, I just decide how about I come up with some overall score attributed to each customer based on the attribute values and based on the relevance of each of these factors, right? So for salary, let's say I said salary seems to be an important point, right? So let me give it a value of 6, like a weightage of 6 as such, right? Because I felt that this is like really important. And on a scale of 10, I'm going to give like different attributes, like different weights. So I thought salary looks pretty important. Okay, leave 6, let me give it 8, right? So 8 times x1, whatever x1 is. And then debt, well, if you think about debt, it's not as good, right? If a person has a huge amount of debt, right? And if they have like some lower amount of debt, then that's good, right? So in a way, this factor impacts my score negatively, because that's going to be my basis for giving out and like approving an application or not. Okay, so I know that this impacts inversely, and then maybe it's important, maybe to some extent it is important. So I'm going to give this a weight of like 4, and I'll say minus 4x2, and then year, maybe 2x3, maybe this is important, years in residence, and then maybe their age is also important. So because like depending on how many years have they like, do they have some other credit history or not, and based on that I'll decide. Okay, yeah, age is also moderately important, so x4 and so on. Like it depends on whatever features you have. Maybe there is some feature which doesn't really impact my score because it doesn't really impact the fact whether I'm going to approve this application or not, so I can give the weight 0, right? 0 to some x of n, and so on, it goes until x of d. Okay, so now that I have this, I can give it a more generic form because these are the variables, right? And I'm deciding based on some predetermined knowledge of the domain, right? And so I just gave these numbers. We can be more generic, and we can say that let's assume that this is because these are weights, so we are using W. This is going to be W1, W2, W3, and so on, right? So we can write a more generic equation for a score, which is W1 x1 minus in this case. But here if you look at it, I could say this weight is a -4, right? So I can, like, because I'm trying to be generic, I would just like still assume this is a plus, right? And this can have any value, for example a negative or a positive. So that's what I'm trying to do here. X2 plus W3 x3 and so on, right? WD xd, right? So now my problem was to approve or decline, right? So based on some threshold, which is again a predetermined threshold, let's say the value 50 or 100, I don't know, like some predetermined threshold, I'm going to accept and decline, right? So basically my rule here of approving or declining will become if score is strictly greater than some predetermined threshold, which we will decide based on my values in my data, right? If this is greater than 0, then approve. If not, right, if score less than threshold, then decline. So here this looks perfectly okay to me. So we have come up with some rule, right, some model that will help us decide whether, when an incoming customer comes in, whether I should be approving or declining a particular credit card application. Okay, so this gives us some kind of like a basic idea of how we are going to proceed further, right? What I'll do is I'll take a break at this particular point, and we will more formally come back in the next video and start talking about this simple learning model, the perceptron, and how this derivation is going to help us go from there to here, right? So let me just pause this video and come back in video 2. Thank you.